Today's topic is Grignard reagent. Grignard reagent is a organometallic compound. It can be represented as R, Mg, X. R is alkyl or it is aryl group. X is halides. So Grignard reagent can be represented as R, Mg, X. It is an important synthetic reagent which is highly useful in the different carbon-carbon forming reaction to synthesize valuable complex organic compounds. So I am going to write an example for a Grignard reagent. Phenyl magnesium bromide is an important Grignard reagent. It is acted as a strong nucleophile because it contains carbon magnesium bond, which is highly polarizable bond. Upon polarization, it forms a partially negative and partially positive species. The charged species can be represented as like this. This is a phenyl anion. The phenyl anion is acting as a strong nucleophile because it is electron-rich species. So once the phenyl anion is formed, it readily reacts with different electrophiles like alkyl halides, carbonyl compounds, and carbon dioxide, etc. So how the phenyl anion reacts with electrophiles and what are the possible products are formed? Let's see one by one. First I am going to start with carbon dioxide. This is phenyl anion, right? It readily reacts with carbon dioxide. The phenyl anion directly attacked at the electron deficient carbon center via nucleophilic attack, followed by carbon oxygen double bond cleavage and abstraction of the positively charged species to form magnesium carboxylate intermediate. The intermediate further undergoes acid hydrolysis to form acid hydrolysis means one hydrogen goes here, one hydroxy group goes here to form neutral carboxylic acid and magnesium salt. Magnesium salt. This is first example. Second example, the phenyl anion readily reacts with aldehyde. I have taken simple aldehyde called acetaldehyde. So the phenyl anion readily reacts with acetaldehyde. What will happen? The phenyl anion directly attack the carbon electron deficient carbon center, followed by carbon oxygen double bond cleavage and positively charged species abstraction to form corresponding intermediate like OMgBr hydrogen CH3. This is magnesium alkoxide intermediate. The intermediate further undergoes acid hydrolysis to form one hydrogen goes here and one hydroxy group goes here. To form CHOH CH3. This is a secondary alcohol. Additionally, magnesium OH Br salt is formed. So the phenyl anion reacts with acetaldehyde to form corresponding secondary alcohol. Third example, the phenyl anion reacts with ketone. I am going to take a simple ketone called acetone. What will happen? The phenyl anion readily reacts with acetone, particularly at the electron deficient carbon center, followed by the carbon oxygen double bond cleavage and magnesium bromide positively charged species abstraction to form corresponding alkoxide intermediate, magnesium Br, CH3, CH3. The alkoxide intermediate undergoes acid hydrolysis to form corresponding alcohol, CH3, CH3OH. Tertiary alcohol plus magnesium OH Br, magnesium salt. Like this, the phenyl anion reacts with ketone, particularly with acetone, to form a corresponding tertiary alcohol. Likewise, the phenyl anion reacts with carbon dioxide to form corresponding carboxylic acid, and the phenyl anion reacts with acetaldehyde to give corresponding secondary alcohol. The phenyl anion reacts with acetone, gives corresponding tertiary alcohol. Like this, the phenyl anion can be reacted with different electrophiles to form complex organic compounds. Thank you.